Alright, we're going to look at covalent bonds now and how to draw Lewis dot diagrams for covalent compounds. So we'll begin by starting the way we have before. So we're going to look at the example of NH3. So I'll begin with nitrogen. And when you're dealing with covalent compounds, try and find the central atom. The central atom is going to be typically the thing that there's one of or less of. So in this case, there's one nitrogen and 3 hydrogens, which makes nitrogen my central atom. And then I have hydrogen. They're both nonmetals, which means they're both going to have high electronegativity. They're both wanting to pull an electron towards themselves. So I'm going to arrange my hydrogen atoms where there's potential bonding sites. So anywhere there's one single electron, like I have here and here and here, those are places where I can bond other atoms. So I'm going to add my hydrogen atom over here, and it has 1 valence electron. Another hydrogen atom here with 1 valence electron, and 1 hydrogen atom here with 1 valence electron. And then we know that covalent bonds share electrons. So in my model of my Lewis dot diagram, I'm going to show that by circling the pair of electrons that are being shared. So that is the first step of my Lewis dot diagram. It shows with my circled pairs of electrons that those electrons are being shared between the 2 atoms. And again, that's true because both atoms have high electronegativity and they both want to pull an electron towards themselves. The second step of drawing a Lewis dot diagram for that is to show the resulting bond. So here's nitrogen, and I'm going to draw a line in the place of that circled pair of electrons. So that would be both steps of a Lewis dot diagram for, in this case, NH3. Let's look at a couple more examples. We'll look at an example of F2. So, in this case, there really isn't a central atom. There's just 2 atoms. So I can just start with fluorine. Fluorine has 7 valence electrons, and my second fluorine atom is the same. Again, I'm going to draw my Lewis dot diagrams in such a way that my bonding sites line up with each other. So now, circle that pair of electrons. I have a single bond between 2 fluorine atoms. Again, when you're going through this process, it helps to count electrons. We go back to the octet rule. Atoms want to have the electron configuration of a noble gas. So if we go back to our first example, this nitrogen atom now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. I'm counting all the electrons that it has by itself, as well as all the electrons that it is sharing. Each hydrogen atom has 1, 2. And though that's not 8, remember, helium has only 2 valence electrons, and in this case, hydrogen wants to be like helium, having 2 valence electrons. Each of these fluorine atoms has 1, 2, 3, 4, 5, 6, 7, 8. Again, you have to count the shared electrons, the circled electrons, for both. That's important because, let's look at an example of something that's very important to all of us, O2, which is oxygen gas. So again, no central atom. So oxygen has 1, 2, I'm going to start that one over. I'm going to mess that one up. So oxygen has 1, 2, 3, 4, 5, 6 valence electrons. 1, 2, 3, 4, 5, 6 valence electrons. So we're going to share a pair of electrons. And now we have a bond. But if I count, each one of these oxygen atoms has only 1, 2, 3, 4, 5, 6, 7 valence electrons. they have not satisfied their octet rule. So what they're going to do is share another pair of electrons. And now, when you count, they have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, because they're sharing 2 pairs of electrons. That results in what we call a double bond. Since they're sharing 2 pairs of electrons, we draw 2 lines between those symbols. And then we can look at an example of N2. Nitrogen has 1, 2, 3, 4, 5 valence electrons. Share this pair. Now they have 6. Share this pair. Now they have 7. Share this pair. Now they have 8. Again, let's count. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons for each nitrogen atom, and that creates a triple bond. So as you are working through a Lewis dot diagram for a covalent compound, it's important to count your electrons to make sure that you have 8 valence electrons in each atom, or 2 for a few elements that want to be like helium.